Today I'm going to help you with some of the problems from chapter 9. Chapter 12. So these are some that you requested. Alright, first we'll take a look at question number 4. So in question number 4, what it is giving us is telling us that there's this statistic or this parameter out there that has a sampling distribution with, its mean of 100 and a standard error of 12. And this problem also gives us the degrees of freedom. So this sort of summarizes the data here. You have a mean of 100 and a degrees of freedom of 12. So the question is, assuming we took a sample and it actually came from this, how likely would it be for us to get a mean of 107? So we've done problems similar to this using normal distributions, but for this one we're going to be working with a t-distribution because we don't know what the the population standard deviation is. Okay. Alright, so we use the formula that you've seen before for the t-statistic. So it would be our statistic minus the hypothesized value, remember this was the parameter, the hypothesized value, divided by the standard error. And all those values were given by the problem. So there's what the value is, right? Now that was correct in the answers there. What was incorrect was the probability, all right? So if you take this value and you put it into the t calculator with this degrees of freedom and hit calculate, this is the probability you get. Now we would compare that to alpha, which typically is 5%. As you can see, it's much greater than 5%. So this is a non-significant result. Okay, so those are the answers for 4A. You work 4B essentially the same way. It's just a different score. And again, the answers were incorrect in the guide, but I provide what the t-statistic should be in the PowerPoint. Okay, now I want to look at 9, which is somewhat more important because it's more similar to what people usually do in science. All right, so let me just make sure we're in focus here. Okay. All right, so number 9 takes data that's presented in question 8. So in question 8, what we had there is we had individual people who would try and throw darts with their preferred hand. So in my case, I guess it would be my right hand. So I'd get a score throwing with my right hand. And then we'd use the same person to throw the dart with their left hand. Okay. So that would be a correlated t-test because you have individual subjects. So we work that one different than we would work 9. Because question 9 is saying, well, what if you had 2 sets of people? So in other words, if I'm in one group, maybe I'm just throwing with my preferred hand. But then we have other people in the other group. Okay. By the way, for an actual experiment like this, the design in 8 would definitely be preferable to the design in 9, in other words, the independent groups design, because 8 is controlling for individual variation. Like I may be a much better player, you see what I mean, than some other people. Okay, at any rate, so you take the same data and we're going to analyze it. So what this is, we've got 2 different groups and they're independent of one another. And so the 2 groups, these are the null hypotheses we're testing. So the null hypothesis is that there's really no difference between the 2 groups. So the null hypothesis, people throwing with their preferred hand are getting the same score as their non-preferred hand. So that's what I have here, the null hypothesis. And then we're actually going to look at 2 different alternative hypotheses. So one alternative hypothesis is that, well, they are different. Now, if it's a two-tailed difference, then we don't really know who's going to do better. In other words, maybe the preferred groups are going to get higher scores than the non-preferred groups. I mean, you know that's probably what would happen. But we're going to also consider the possibility that you actually get higher scores with a non-preferred hand. So this is a two-tailed probability. That's one alternate that we're considering. Another alternate is a one-tailed test, which is kind of what is probably going to happen. But if we were doing an actual experiment, we wouldn't want to go into it doing a one-tailed test. All right. Okay, so calculating the t-statistic for both of these is the same, and it uses the same formula we had over there in 4. So in other words, you have the statistic minus the hypothesized value over the standard error. This time, though, the standard error is different. So you've seen this standard error written a couple of different ways. What we've got is we've got a difference between means. So remember the difference between means, it can either be written as 2 times the mean squares error over n. You can play around with everything as long as you just have the 2 means and get this formula, which is equivalent to that. One way or another, you're going to be sort of combining the 2 variances of the 2 groups. All right. So over here I have the actual data. So let's take a look at this and see what we will do with it. All right, let me make sure this other panel is in focus here. Looks good. Okay, so if you take the data and put it in something like Excel, you can calculate means, or you can do it with a handheld calculator. It would just be more time consuming. But the mean of the preferred group is 10.6. And the mean of the other group, you know, the ones where they're not using their preferred hand, is 8.6. And notice I put a U here. That really should have been an N. That's what I had in the previous panel over there, so we'll stick with that. And, all right. So if you calculate the variances of the two, and you got to be careful, this is variance, not standard deviation. 5.3 and 1.3, all right? Both groups have the same sample size. There's 5 people in each group, all right? Now, calculation of the t-statistic, so putting everything in here, remember 0 is the hypothesized value, so it doesn't really affect this very much. So we take the difference between the 2 means. The hypothesized value is the difference between the 2 means is 0, all right? And then here we have, you know, the standard error. So we have the variance of one group minus the variance of the other group divided by n. This is 2 times the mean squares error over n. It's just been simplified somewhat. Okay, so once you go ahead and crank that out, you should get 1.741 as a t-statistic. All right. Now let's take a look at what we do next. So to find out the probability, we're going to need the degrees of freedom. Remember that every time you estimate a variance, you lose the degrees of freedom. And usually when you're working with a difference between means, you have 2 sets of data. Notice we have these 2 variances. So total, we have 10 people. And you may have seen this formula. This is one that Lane likes to use, so I'll use it this time. So for this group, we have, you know, the 5 people, but we lose a standard, we lose a degree of freedom because we have calculated a variance for that group. And then here's another one. All right, so or you can think of it a different way, you know, total number of people 10 minus the 2 degrees of freedom because we're working with 2 variances. Okay, so we have 8 is the degrees of freedom here. All right. Now when you take this t-statistic and those degrees of freedom, put it into Lane's t-distribution calculator, this is the probability you're going to get. As you know, in this class we usually round things off to 3 decimal points, so we would round that off to 0.120. Okay, that's also rounded off to 3 decimal points. Now, when you're taking the quiz in here, you may have to write, in fact, you're likely to have to write sentences rather than just report numbers. So let's see how we would report that. This is the two-tailed test, by the way. So I have that over here on the last panel. Make sure we can see. Okay. So this is how you would report those values. We failed to find a difference between the groups. And then notice I have a T with 5, 5 as subscripts. That tells me that I had 5 individuals in each group. I put the T statistic rounded off to 3 decimals, so 1.741. And then here's the probability, 0.120, also in parentheses. Notice that you don't need to say non-significant because, that's communicates that fact to people. So saying anything like non-significant would be redundant. You don't need to say it twice. Okay. Now the second question on 9 is asking for the one-tailed probability. Remember we said we were going to do that as well. So what we're doing when we're calculating this probability here, this is a t-distribution. And if you're doing a two-tailed test, this probability is the area at either one. You see what I mean? On the other hand, if you're doing a one-tailed test, you sort of get the same distribution, but you're only looking at that end of it. So since this t-distribution is symmetrical, we need to know what just one of those areas are, and the two sides are the same. So to find the one-tailed t-distribution, it's 1/2 of the probability for the two-tailed distribution. And the calculator we're using calculates a two-tailed probability. So we would just take the value that we got and divide by 2 to get the one-tailed probability. Now, if we were going to report that, so, report the one-tailed probability, you'd just say essentially the same thing. The only difference would be that in the probability place, you would put that instead of 0.120. Okay, so what I'm going to do now is go over to the computer to show you a couple of things we can do with this data set. All right, so I'm going to move the camera over there, if you'll bear with me for a minute. Okay, let's see how this is going to look. I think we'll need to put this down too. There we go, so everybody can see what's going on here. Okay, there we go. Let's see here. All right, that looks good. Let me just log back in here. Okay. All right, so I used Excel to calculate some of these things. And, you may want to use Excel for a problem like this. As we're going to see, you can actually do this with past as well. So the way I set this up in Excel, and I'll put this on D2L so you guys can take a look at it, I just pasted in the data. Now, just pasting that data in was sort of a pain. I had to first copy it and then paste it into Word, and then copy it from Word and paste it into Excel and remove formatting. So all that was kind of a pain. At any rate, let's see. So then I just had Excel calculate the mean for me and the variance for me. I actually calculated the mean squared error here, but you don't have to do it that way necessarily. And the sample size. So all these are actually formulas. As you can see, those are averages. Here we have the variance formula, if you look at the formula bar at the top. So a mean squared error is essentially an average of the variances. Let's see, there's n, that's a count. I had it count it for me. I could have counted it by hand, it's not a lot. Here's the formula for the standard error. Okay, so notice it's 2 times the mean squared error over n, square root of that. And then here's the calculation of the t-statistic. Okay. Anyway, so that is stuff that we've done in class. So you probably, well, no, that I showed you guys before, I think. So I assume you can probably figure out how to do most of that. All right, what I wanted to show you is what we can do with past. Okay, so I'm going to copy that data. Now don't, copy the other stuff. We don't need that. That'll screw everything up. Okay, so control copy. Now I'm going to open past here. All right, we're going to go ahead and put in or click the column attributes so we can have some titles up here. That way we won't lose track of what's what. All right, let me see if we can get in a little closer there so you can see. All right, now, when you have actual data, we can test assumptions. So this is something you're going to have to be able to do on the test, even though Lane doesn't really talk about it. So I'm going to do both columns. So first, let's test the assumption of normality. Remember, you click univariate, go down to normality test there. All right, notice nothing shaded. That's good. That means that we have satisfied the assumption of normality. Notice the probabilities are greater than 0.05. So you could say something like, we satisfied the assumption of normality for the preferred sample. This is the statistic and the probability. And for the non-preferred sample, this is the statistic and the probability for that test. All right. So another assumption, remember, is that the population variances are the same. So to do that, we go here to two sample tests. All right. Two sample tests, F and T, etc. It's the F test here. This is a test of equal variances. See, it says that, test for equal variances. There's the F value. Here's the probability. Again, notice the probability is greater than 5%. So we have satisfied the assumption of homogeneity of variance for this data. Now, it's possible to actually do the whole t-test in here since we have all the data. Notice there's the same t-statistic that you can calculate with Excel. Here's a probability. So if for some reason you wanted to check yourself, you could always try calculating it by hand, and you could calculate it using past to see if you're getting the right thing. Notice past also gives us some summary statistics as part of this menu. Like there's the mean of the preferred group and the mean of the non-preferred group. Here are those variances we calculated. Okay, so this is a good way to double check. Now, what if you would have violated the assumption of homogeneity of variance? We didn't. If for some reason we had violated it, we could use the unequal variance t-statistic and probability instead of this t-statistic and this probability. Violations of normality, as long as they're not really dramatic, well, they usually don't affect the results too much, especially when the sample sizes are the same. So a lot of times you don't even need to worry about those. So anyway, that's where we'll end with this particular part. Okay, let me just be sure everybody can see this. I need to move this whole window and it is not moving. Well, okay. All right.